Now we're going to continue looking at how we can set up inequalities to help us solve word problems. And the ones that we're going to look at today will be two-step inequalities. And just like with any type of word problem, you want to read it through twice. So we're going to read it through first to make sure that we understand what the problem is about. And then we'll read it through a second time to look for specific information that will help us to set up our inequality so we can solve it and answer the question. So here's our first word problem. Jerry has $17.50 and is going to the movie theater. A movie ticket costs $10 and snacks are $2.50 each. What is the maximum number of snacks she can buy? So looking at the first sentence, it says Jerry has $17.50. So that means that that's the most that she can spend. So all of the money for the ticket costs and the snacks have to be less than or even equal to $17.50. She just can't go over that amount. So we can set that up as the cost of the tickets and the snacks is less than or equal to $17.50. We're also told that the movie ticket costs $10 and snacks are $2.50 each. So we can break down the cost of the ticket and snacks using that information. The ticket is $10. And then for the snacks, it says that they're $2.50 each. So to find the total cost of the snacks, we'd have to multiply $2.50 times whatever number of snacks she decides to buy. And we don't know how many snacks she's going to buy, so we don't have a number to put in for that. We'll just leave it as words. But we do know that all of that, all the total for the tickets and the snacks has to be less than $17.50. So we really do have an inequality already set up here. 10 plus 250 times whatever number of snacks she buys is less than or equal to $17.50. But we normally don't solve inequalities when they're set up like this. So let's clean this up a little bit. Instead of writing number of snacks, let's use a variable like n. So we can write this over as 10 plus 250 times n is less than or equal to $17.50. And now we can solve our inequality. So let's focus on the left side where our variable n is so we can get n by itself. First, we'll subtract 10. Do that on both sides. And we'll see what we're left with. 10 minus 10 will cancel out. So on the left, we'll just have the 250 times n. And on the right, we have 1750 minus 10. That would leave us with 750 on that side. So if we bring that all down, we have 250 times n is less than or equal to 750. Now to get n by itself, we'll need to divide by 250. Do the same thing on the other side. 250 over 250 will cancel out. So on that side, I'll just have n left. On the right side, 750 divided by 250 will equal 3. So that becomes n as less than or equal to 3. So that's our solution, is that n, which represents the number of snacks, is less than or equal to 3. Or to put it in terms of the word problem, we could say that Jerry can buy a maximum of 3 snacks. Let's look at one more example. The length of a rectangle is 3 centimeters more than its width. The perimeter is less than 38 centimeters. Write and solve an inequality to find possible values of the width. So we know that we have a rectangle, and there's some information about the length and the width and even the perimeter of the rectangle. Well, to help us picture what's going on, let's draw a rectangle. And let's label one side as the width and the other direction we can label as the length. Now let's look at the word problem to see what other information we can find. So it says the length of the rectangle is 3 centimeters more than the width, but we don't know what the width is. So we'll use a variable. Let's use W to label the width. And the length is 3 centimeters more than the width. So that means that we can write the length as W plus 3 to represent the 3 more centimeters. We're also told that the perimeter is less than 38 centimeters. So let's write that as an inequality. And we can just use the word perimeter with the less than sign and 38. Now let's think about what we know about perimeter. We know that the perimeter has to be the sum of all the sides of the rectangle. Basically, if we add the lengths of all the sides, that will equal the perimeter. So, if the left side of the rectangle is represented with W, then the side across from it also has to be that same measurement, whatever W is. And if the bottom side is W plus 3, then the side across from it at the top has to also be the same measurement. So we can label that as W plus 3. Now if we add all those sides together, that's equal to the perimeter. So let's break the perimeter down into the sum of all those sides. So we have the left side is W. Then we'll add the bottom side, which is W plus 3. Add the right side, which is W, and the top side as W plus 3. So we have all of that being added together. And that total of the perimeter is less than 38. Now we have a bunch of W's in there and a couple 3's, so we can definitely combine like terms to simplify this inequality. And if we do that, it will simplify to 4W plus 6. We have the 4 W's there, and 3 plus 3 gives us 6. And that is less than 38. So now we have an inequality that's much clearer to work with, and we can solve for W. So we can subtract 6 from both sides. The 6 minus 6 will cancel out. So on the left, we'll just have 4W, and on the right, 38 minus 6 will leave us with 32. So this becomes 4W is less than 32, and then divide by 4 on both sides. 4 over 4 will cancel out, and on the right side we have 32 divided by 4, which is 8. So this becomes W is less than 8. So our inequality is solved. We know that the width has to be less than 8. And if we write it out as a sentence, we would say the width of the rectangle is less than 8 centimeters.